Welcome to the Minerals Lab. First, we'll start with some background information to provide you context for this week's lab. We'll begin by defining a mineral. A mineral is naturally occurring, inorganic, homogeneous solid that has a definite or slightly variable chemical composition with an orderly internal atomic structure. Any product that is human-made or is not a solid is not a mineral. The compositions of mineral compounds have specific ratios of elements, but substitution of atoms can occur. Most people think of the listing on the side of a box of cereal or the gems in a jewelry store when someone says minerals, but to geologists, minerals are the building blocks of the world around us, like atoms are the building blocks for chemists. Minerals are more important in our daily lives than most people imagine because they provide the raw materials that we refine to make many products. Minerals are very important, and we will begin our discovery of Earth by learning how to identify minerals in an orderly sequence and learning some of their common uses. Now, we know the definition of a mineral, but we want to know how that's different from a crystal, because sometimes those two words are used interchangeably. A crystal is a type of solid whose atoms are arranged in a highly ordered repeating pattern. There are three key differences between minerals and crystals. All crystals, specifically those that are inorganic, are minerals. Not all minerals form crystals, and crystalline structure gives minerals their geometric external shape. So in summary, atoms or molecules are arranged in an ordered, repeating 3D pattern, and that is reflected in the external crystal shape. Now, what is the difference between minerals and rocks? Rocks are naturally occurring and coherent aggregates of one or more minerals. Key differences between minerals and rocks include minerals have a specific chemical composition while rocks do not. Minerals are building blocks that make up rocks. Rocks can be composed of many different minerals, and minerals are defined by chemistry while rocks are defined by how they formed. Minerals can be identified and classified by their physical properties, including color, luster, cleavage, fracture, hardness, streak. Other properties like taste, magnetism, crystal shape, specific gravity, and also aid in mineral identification. By analyzing physical attributes, earth scientists can identify mineral samples and infer how they formed. All minerals have a color, but this can be misleading. The only definite use of color for identifying minerals is for describing streak. Color should not be used to describe the appearance of minerals. Several samples of the same mineral can have different colors. This is because as a mineral is forming, some impurities are included that can change the mineral's color. For example, manganese impurities in quartz give it its purple color. Keep in mind that color and luster are separate properties. If needed, it's best to say that a mineral is either light-colored or dark-colored. Luster is a description of the way that a mineral reflects light. There are two basic types of luster, metallic and non-metallic, and that's what we'll use for today's lab. Minerals with a metallic luster look like metals. Non-metallic minerals do not look like metals. For our purposes, describing the luster of a mineral as metallic or non-metallic is sufficient. However, we can further describe non-metallic luster by comparing their appearance with common items. Minerals that appear glassy are said to be vitreous. Other non-metallic descriptions include dull, earthy, waxy, or pearly. Hardness is one of the most useful properties of minerals. Hardness is a measure of the mineral's resistance to abrasion or scratching. A harder mineral will cut or scratch a softer material. We use simple household items of known hardnesses to determine the hardness of mineral samples using the Mohs hardness scale. This was developed by a German scientist named Friedrich Mohs to compare the hardness of minerals. The scale, where 1 is the softest and 10 is the hardest, lists 10 index minerals that represent each number on the scale. The softest index mineral is talc, while diamond is the hardest. Note that hardness does not increase uniformly as the number increases. For example, a diamond is more than 10 times harder than talc. Crystal form or habit. The atoms that combine to form the crystal composition are arranged in a repeating 3D pattern that forms a skeleton or a crystal lattice. This basic pattern is repeated over and over until the mineral is large enough for us to hold. This pattern and the properties produced by the bonding of atoms in the mineral give the mineral certain physical properties that we can use for identification. If a mineral grows in an unrestricted environment, or where it does not need to compete for space, it obtains a crystal form or a crystal habit. The shape of minerals with crystal form reflects the internal structure of the crystal lattice. Minerals with crystal form have many flat sides called crystal faces. Cleavage is the tendency of a mineral to break along planes of weakness. We will refer to these planes as directions of cleavage. Sides broken along a cleavage direction normally form flat surfaces. This ability to cleave, the number and directions of each plane, are caused by weaker bonding between planes within the crystal lattice. A description of a mineral's cleavage includes the number of cleavage planes and the angles between those cleavage planes. The angle between cleavage planes is measured with a goniometer. Two cleavage surfaces parallel to each other are grouped as one direction of cleavage. Be careful not to confuse cleavage surfaces with crystal faces and vice versa. Minerals that do not have cleavage have fracture. This means that the mineral has no planes of major weakness in the crystal lattice and therefore breaks in a random pattern. Fracture generally can be described as irregular, but there are several other types. If the mineral fractures like glass, it has conchoidal fracture, like the curve of a conch seashell. If it splinters like wood, it has splintery fracture. The streak of a mineral is the color of the fine powder left after scratching the mineral on an unglazed porcelain plate, known as the streak plate. In this case, the color is useful, not just light or dark, especially for the metallic minerals. The color of the streak is the true color of a mineral. Some minerals have streak colors that are different than the colors of the mineral's surface. Some minerals do not leave a streak because they are harder than the streak plate. The specific gravity of a mineral is a dimensionless number that represents the ratio of a mineral's weight to the weight of an equal volume of water. This is different from the mineral's density, which is the weight of the mineral divided by its volume. This is done simply by hefting two minerals of nearly equal size in the palm of your hands. You may notice that one of the minerals feels heavier than the other. If so, the heavier one has a higher specific gravity. Striations are closely spaced, slightly grooved, or indented lines on the crystal faces or cleavage surfaces of some minerals. They look kind of like the grooves on a record album. Plagioclase feldspar is an example of a mineral with striations on one cleavage surface. This is the only way to distinguish the two feldspar minerals, plagioclase and orthoclase. There are several special properties that can help you identify a mineral. The first is a reaction with acid. Some minerals will react with acids. Calcite will effervesce or fizz as carbon dioxide is released when the mineral reacts with hydrochloric acid. Calcite is one of the minerals in the carbonate group. Dilute acid is normally used to determine if the carbonate minerals are in a rock. However, calcite has other diagnostic properties, especially its rhombohedral cleavage, that should be used for identification before the acid test is considered. Please observe the safety information if you decide to do this test. Another special property is magnetism. Some minerals are magnetic, that is, they attract other magnets. To test for this, bring a small magnet near a mineral. if it is magnetic, the magnet will be pulled onto the specimen. Normally, only magnetite is magnetic, but occasionally hematite will also be slightly magnetic due to small amounts of magnetite mixed into the sample. Some minerals have a distinct taste. Halite tastes like salt. This is not something that you should test for unless you have a fresh surface. Ask your TA if a sample has a salty taste. Please do not taste anything in the lab. Finally, some minerals have a distinctive feel. Talc feels soapy and graphite feels greasy. Next, we'll discuss information that you'll need to complete this lab. This lab has several safety considerations. We will be using hydrochloric acid. This is probably the biggest safety consideration for this lab. Use only 1 drop of acid when testing for a reaction. This dilute acid is a skin and eye irritant, which can cause redness, a burning sensation in the eyes, and can discolor or dissolve clothing. In the case of skin or eye contact, flush immediately with lots of water. Neutralize any spills with baking soda and wipe up immediately with a paper towel. Dry off the area and notify your TA. Glass safety. We will be using glass plates to test the hardness of mineral samples. It is extremely important that you hold the glass plate flat against the tabletop. Do not hold the plate in your hand while you're doing the glass test. Do not taste any of the minerals. A special property of some of the minerals is a salty taste, but if you suspect a mineral may have a salty taste, please ask your TA and they will confirm. Wash your hands immediately after the lab to remove any remaining mineral residue. And finally, be sure to clean up after yourself and be considerate of your TA and your peers. There are no helpful hints specific to this lab. Mineral test kits will be provided by your TA. These will include dilute hydrochloric acid, a glass plate, a streak plate, a nail, a copper penny, and a magnet. Mineral identification flowcharts will be provided by your TA, but will also be available on the instruction page in this week's Carmen module. Finally, all mineral samples will be provided by your TA. The only 2 digital items of this week are PDFs. The first is a PDF of the mineral identification flowcharts, and the second is a PDF of Mohs hardness scale that you can use as a reference guide as you're testing the hardness of your mineral samples. These are both available on the instruction page in this week's Carmen module.